which is nothing but the topic that most of the time the students were waiting, and that is related to mathematical logic. So in today's session, we will go and we will talk about what is the application that is related to, or what is the use of mathematical logic. See, the many times the student used to ask that, sir, can you tell me that, the real-time application of a mathematical logic, or can you tell me that how we can use this mathematical logic in we can say that into normal life, or what is the exact you can say that the application of a mathematical logic. So today we'll go and we'll talk about that particular concepts that is related to mathematical logic. So here I welcome to all of you on this India's largest e-learning platform, Gradeup. So we'll go and we'll talk about the today's topic, that is nothing but mathematical logic. But before that, let me tell you about myself. My name is Satish Yadav. People also call me researcher or Baba, because I have done a lot of research into different areas of a computer science, and I have taught more than 1 lakh of students and throughout the whole India, across all the cities. And my areas of expertise are discrete mathematics and you can say that DBMS. So we'll go and we'll talk about the mathematical logic. But before that, let me tell you about the Gradeup Super subscription. See, many times the students they want to prepare for a particular examination. Suppose if you want to prepare for a particular examination, then what will happen? You think that I will prepare for this particular examination, but I am not getting a proper structure schedule. I don't know from where what to study. I don't know which type of reference book I have to use, or what type of concepts that I have to grab, or what type of questions that I have to solve, or what are the quizzes that I have to take. So in order to do that, here the Gradeup is providing the super subscription so that your plan will be structured. So for the whole year, the Gradeup will giving you this particular plan, okay, so that you can watch this particular type of the plan. See, for example, if someone says that I am going you, or I am providing you, let's consider suppose if I am providing you the whole year plan or the whole year structured plan, something like that, then the Gradeup is providing you that. So see, what are the advantage of having the Gradeup subscription? You will be having a 600 hours of live classes. You will be having a 5,000 of practice questions. You will be having hundreds of mock tests. You will be having the chapter wise notes also. You will have the quiz also. These all are the advantage that is related to what? That is related to Gradeup Super Batch subscription. So once you will take a Gradeup Super subscription, the advantage that you people are having is basically what? The advantage that you people are having is basically you all are getting this extra things. Now, in order to take the subscription, you can contact on this number, and I'm sure our team will be assisting you in a best possible way. So 9650052904. That is nothing but the thing. Anyhow, if you want to understand about the other batches, what the Gradeup is coming and what the Gradeup will be teaching, so here the upcoming batches will be there. Okay. Already the batches are going on, but still you can enroll for the other batches. Now, if see on a Gradeup app also, so those people who have not downloaded the app, you can also download the Gradeup app, because in Gradeup app we are teaching most of the times the free sessions, okay, over here without subscription. So here the sir is taking, which is nothing but everyday class. So you can see that here the sir is taking the class at 6 p.m. I am taking a class every day at 5 p.m. The sir is taking the class at 11 a.m. Okay, so all the faculties, all the the experts faculties are taking the classes. You can note down the timings also. Okay, suppose if you want to do a practice with respect to my subject, so every day 5 p.m. on a Gradeup app, you can come and you can join me. Yes, today also you can come and you can join me. Okay, these all are the advantage, and here you will be having one of the benefits that you people are getting with respect to Sahi Prep ka prime time. Anyhow, we'll go and we'll start. Okay, we'll go and we'll try to start, which is nothing but which is nothing but mathematical logic. Yes, Sagar, I know. Okay, so here we will go and we will try to start, which is nothing but mathematical logic, and we'll go and we'll talk about what is a mathematical logic or what is the application that is related to that. See, many times the student used to ask me what is the mathematical logic, or what is you can say that the concepts of a mathematical logic. or why it is used into that. See, most of the times the students are saying that, see, you are having, which is nothing but programming language, and from a programming language, what you will do is basically you are drawing the software. So from a programming language, you are making to a software. And then we are thinking the computer science is over, but the computer science is not over. There are various things into that. First of all, you should be having the algo, and then from algo you will be having the programming language, and from programming language you will be converting to software. But obviously we cannot use the algorithm as it is. See, suppose if anybody is saying that can you draw this particular software, so what you are doing is basically first you should know the algo, and then from algo you are using into programming, and then from programming you are making into software. But in order to use the algo, you should have a theorem. Okay, you should have a theorem. But sir, where is this mathematical logic? The mathematical logic that you people are having over here is basically in order to prove the theorems. So once you will prove the theorems, then you can use into the algo, and then you can use into PL, and then from PL, so you can have a software. But theorem is not just a straightforward statement. Theorem is not just a straightforward statement. In order to prove the theorems, there are multiple statements that leads to a single statement. There are multiple statements. See, when we are deriving any particular theorem, so there are multiple statements that leads to one statement, and that is called as what? That is called as a conclusion. So here, what you will be having? Here you will be having the conclusion. Okay, now what will happen? See, now what will happen? This is one particular statement. This is another particular statement, another particular statement, another particular statement. These all statements leads to a one point that is called as what? That is called as a conclusion. Now this conclusion is called as a theorem. Now from a theorem, theorem to algo, algo to PL, PL to software. Sir, where is mathematical logic? Mathematical logic, it gives us power. Mathematical logic, it gives us power to check the validity of this statement, to check the validity of this statement, to check the validity of this statement. So if anybody will be asking what is the mathematical logic or what is the real-time application of mathematical logic, then you have to say that a mathematical logic, it gives us power to check the validity of a statement. So to check the validity of a statement. So most of the times when you will learn about the mathematical logic, it gives you power to check whether this theorem is valid or not, to check whether this statement is valid or not. Now, okay sir, I got the why we are learning the mathematical logic, to check the validity of a statement, whether to check the statement is valid or not. Okay, so that is nothing but the main concept why we are learning the mathematical logic. Now here we'll go and we'll talk about this particular statement. See, if I will be having, which is nothing but this type of statements here, and here you will be having a theorem. Sir, I'm not getting how you are writing the statements and then you are writing the theorem. Okay, now what I will be having is basically, if I will say that if I will say that suppose in 10th grade or in 8th grade or something like that, then what you are writing is basically, you suppose if somebody says that prove that sine square x plus cos square equals to 1, then you cannot directly prove that. So yes, what you are doing, you are writing the steps. You are writing sine 30 is something, you are writing cos 30 is something, and then you are writing sine square 30 equals to something, you are writing cos square 30 equals to something, and then you are proving. My point is, theorem, in order to prove the theorems, we are not directly proving the theorems, but we are writing multiple statements and then we are proving it. From where we are taking these statements? We are taking these statements not just randomly. We are taking this statement from a set of English statements. So here you will have what? Here you will have a set of English statement. So here you will be having what? Here you will be having a set of English statement. But again, in a set of English statements, there are certain different types of statements. If there is a set of English statement, there is a different type of statements. There is a ordering statements. There is a questioning statements, exclamatory statements, imperative statements, but we don't take all the types of statements in order to prove the theorems. We are taking a selected type of selected type of statements, and that statements that comes from English statements, those type of statements are called as a factual statement. So we are not, see, again I will go and again I will tell you, we are having the statements. Based on these statements, we are giving the theorems. These statements we are not just taking randomly from here. We are taking these statements from a particular set, and that set is called as what? That set is called as a factual statements. This set, the English statement, it is made up of different statements. It is made up of questioning statements. It is made up of ordering statements. It is made up of exclamatory statements. We does not take all the statements, but we take a type of what? We take the selected type of statements, and that selected type of statements are called as a factual statement. Now, if anybody asks what is a factual statement, then you have to say that a factual statement is basically a type of statements that defines the facts. What is that fact? The fact is basically either true or a false. So here we'll go and we'll talk about, in mathematical logic, this type of factual statements are called as a propositional statement. So here I am having that propositional statement. So now we'll go and we'll talk about this type of statements, and that is called as what? That is called as a propositional statement. A propositional statement, it is a type of statements that defines the facts. As I told you, a propositional statement is basically, you can say that, a factual statement. So that defines some facts. Either it can be going to be true, or it is going to be what? It is going to be false. So either it is going to be true or it is going to be false. It defines some facts. Now, okay sir, I understood your flow, but propositional statement, it is of two different types. One, you can break it, other one, you cannot break it. So if I am talking about the propositional statements, there are two different types of propositional statement. One, you can break it, one is breakable, another one, you cannot break it. Another one, you cannot break it. Okay, another one, you cannot break it. So one is called as what? One is breakable, another one is not breakable. When it is not breakable, that means you cannot break it, that is called as a simple propositional statement. That is called as a simple propositional statement. Okay, that is called as what? That is called as a simple propositional statement. So if anybody is saying that what is a simple propositional statement, then you have to say that a simple propositional statement, it is a type of factual statement where we cannot break it. When you can break it, that is called as what? That is called as a compound propositional statement. That is called as what? That is called as a compound propositional statement. Compound propositional statement. So here you will be having compound propositional statement. Now, if I will be talking about a simple, sir, can you give me example where it is a simple propositional statement or a compound propositional statement? Let me give you that example. Suppose if I will write 5 is greater than 3. This is called as a simple propositional statement. Why? You cannot break it. Or you may have also learned this type of things as that, the people are saying that Chennai is a capital of a Tamil Nadu. For example, this is a one simple statement. This is a statement where you cannot break it. If you cannot break it, then what will happen? That will become the simple propositional statement. But when you can break it, that is called as what? That is called as a compound propositional statement. So here you will be having what? Here you will be having a compound propositional statement. So you will be writing 5 is greater than or equal to 3. See, this is called as what? This is called as a compound propositional statement. A compound propositional statement, it is a type of statement where you can break it. So suppose if I will write 5, one example, if I will write 5 is greater than or equal to 3, then what I can write is basically 5 is greater than 3, or here what I will be writing, 5 is equals to 3. So this is called as what? This is called as a compound propositional statement. Yes or no? Now what I can write is basically here compound propositional statement, you can break down into 2 or 3 or 4 simple type of statement. So here you will be getting what? Here you will be getting one simple statement, and here you will be getting what? Another simple statement. So this is the whole concepts that is related to what? That is related to a propositional statement. So propositional statement, it is of two type. One, you can break it, other one you cannot break it. When you can break it, that is called as a compound propositional statement, and then other, when you cannot break it, that is called as a simple propositional statement. So in this way we can go and we can try to understand the whole concept. Now let's go and let's try to derive the other things that is related to that. Now see, suppose what I will be telling you such that if you will have a compound propositional statement. Now if I will write here compound propositional statement, if I will write compound propositional statement, and here if I will write simple propositional statement, simple propositional statement. Okay, so one is called as a compound propositional statement, simple propositional statement. Now here you will be having a compound propositional statement. As we know that compound propositional statement is we can break down into two or more simple statement. So here you can say that you can break down this whole thing into two or more simple statement. Okay, so here you will be getting what? This is your compound propositional statement. You can break down into two simple statement. See, when we are breaking the compound propositional statement, we are breaking at breakable points. Yes or no? We are breaking at breakable points. And those breakable points are called as a connectives into mathematical logic. So here we are breaking at where? Here we are breaking at. This is called as a breakable point. In this slide you can also understand this is called as a breakable points, or this is called as what? This is called as a, you can say that, connectives. So in a compound propositional statement, when we are breaking at some point of time, suppose if this is a pen and if I am breaking it, so I am breaking at breakable points. Those breakable points are called as what? The connectives into mathematical logic. So here this is called this breakable point. So here you will be getting what? It is called as what? It is called as breakable points. Breakable points. These breakable points are called as what? These breakable points are called as a connectives. Okay, these breakable points are called as what? Connectives. So here you will be having the connectives. Connectives, we are having four different types of connectives into mathematical logic. Simple statement, you cannot break it. This is just a simple statement. Sir, what will happen if I will break a simple propositional statement? If you will break the simple propositional statement, it does not have any meaning. Okay, it does not have any meaning. Simple propositional statement, if you will break it, it does not have any meaning. But if you will break the compound propositional statement, you are breaking into either two simple statement or more simple statement, right? Now what will happen here? This is called as a breakable points, and these breakable points are called as what? These breakable points are called as a connectives, right? So here you will be getting one simple statement here. Here you will be getting another simple statement like this. So we are having the four different types of connectives. So we'll go and we'll talk about that. First one, that is called as a conjunction. So here this is called as one connective. Another one, that is called as a disjunction. So this is another, you can say that connectives. And then we are having a single implication. And then we are having what? And then we are having a double implication. These all are the different connectives that you people are having. So one is called as a conjunction, disjunction, single implication, double implication. Sir, I also heard that which is nothing but you can say that modifier, or you can say that negation. Yes, negation is also there, but negation is not the connectives. Negation is basically what? Negation is called as a modifier. So here I will be writing this negation sign like that. So negation is called as what? Negation is called as a modifier. So which negation does not negation does not connects two or three simple statement. What the negations does? Negation modifies the statement. So negation is also called as what? Negation is also called as a modifier. So here you will be having what? Here you will be having the modifier. So it modifies a simple statement. Einstein is a genius. Einstein is not a genius. So it modifies the statement. It does not connect two or more simple statement, right? So that is nothing but this is the whole concept that you will be having. One more thing. See, the very important topic over here is basically, in mathematical logic, we cannot directly define the truth value of any compound statement. In mathematical logic, we can define what? We can define, you can say that in a mathematical logic, we can only define the truth value of simple statement. We cannot define directly the truth value of a compound propositional statement. We can only directly define the truth value of a simple statement. So sir, are you trying to say that we cannot define truth? No. We can define, but not directly, indirectly. Sir, what is the meaning of that? The meaning is basically, if you want to define the truth value of this, then it has to be dependent on simple statement 1 and it has to be dependent on simple statement 2. Now, if I am talking about here this is simple statement 1, this is simple statement 2, and this is compound propositional statement. In mathematical logic, directly we can define truth value. Directly we can define truth value. We can define truth value With respect to what? With respect to simple propositional statement only. That means compound indirectly we can define. We can define indirectly for a compound propositional statement. Sir, what is the meaning of that? I am not getting it. My point is, you can directly define this, you can directly define this, but indirectly you have to. That means in order to go for the truth value, when you want to define the truth value of a compound propositional statement, it has to be dependent on this, it has to be dependent on this. Right? See, this is a compound propositional statement. You know why? This is one simple statement, this is another simple statement, this is connective. So when you want to define the truth value of this, it is dependent on P, it is dependent on Q. That is nothing but my point or the observation. Now, let's see this. So what will happen? Sir, obviously when it is dependent on that, then you will be getting a cases. Yes or no? Then you will be getting a cases. Yes, then you will be getting a cases. So here I will be getting, which is nothing but case number 1. What will happen if both will become a true? So here I'll be having a case number 2. What will happen if the first one is true, second one is false? Now here I will be having a case number 3. Here if it is a false and then it is a true. Now here I will be having a case number 4. So if it is false and if it is a false. So basically truth table is nothing but a case studies of simple propositional statement. So the compound propositional statement is totally based on simple propositional statement. So if anybody is asking what is a truth value, then you have to say that a truth value is basically defined as what? A truth value is basically defined, or truth table. If somebody is saying that what is a truth table, then you have to say that truth table is basically a case studies in order to define the compound propositional statement. So that is nothing but the whole concepts that is related to that. Okay, so that's it for the today, and we'll go and we'll talk about the other sessions. Okay, we'll go and we'll talk about, in the next session we will be talking about the other things. But before that, I'll tell you these all are the rankers. So if you want to prepare with the Gradeup, you can take a Gradeup subscription, and this all are the advantages that you people are having with respect to what? With respect to the Gradeup Super subscription. Now if any person wants to have the assistance, then that person can contact on this particular number, such that 9650052904. So in this way you can have all the subscriptions that is related to that. Okay, thank you so much guys for coming on this particular session, and then we will be having the the certain sessions, and every day at 5 o'clock I will be having a you can say that practice session on a Gradeup app, and it's totally free. So if you wish to join, you download the Gradeup app and then you follow me over there, and then you can come and you can join the practice session. Right now the graph theory practice sessions are going on, so you can join at that point of time. Okay, yes, thank you so much guys for listening this class. Thank you so much and see you. Best of luck.